Greetings, ladies and gentlemen. This is Mr. Braun talking about redox reactions, our day 2 of our redox reactions. If you look up on the board, we can see that our learning target, once again, is to identify a chemical reaction as an oxidation reduction reaction. Our success criteria then are to identify atoms that are oxidized or reduced through electron transfer, to assign oxidation numbers to atoms in a compound and ions, to identify redox reactions by analyzing the changes in the oxidation number for different atoms in a reaction, and then finally, to balance equations for redox reactions through the oxidation number change method. Now, today we're going to talk a little bit about some redox reactions and how we're going to identify these using the oxidation numbers. Now, here is magnesium plus sulfur yields magnesium sulfide. This is just a nice, easy redox reaction because when we look at the results of this reaction, magnesium is transferring 2 electrons to the sulfur, to sulfur. So, if I look in terms of my half reactions here, magnesium yields magnesium 2 plus 2 electrons. So magnesium is losing 2 electrons. Losing electrons is oxidation. If I look at sulfur, sulfur is gaining 2 electrons. Gaining electrons means that we have reduction. Remember old Leo Gurr. Well, let me show you something here with our oxidation numbers real quick. Magnesium, oxidation number 0. Sulfur, oxidation number 0. Magnesium here is a +2. Sulfur here is a -2. So when I look at this and I go from sulfur right here and match those up, sulfur has gained 2 electrons. Because now went from a 0 to a -2. Okay? Gain electrons is reduction. Okay? If I look at magnesium, okay, and I collect those two like this, magnesium went from 0 to +2. So it must have lost 2 electrons. Lose electrons, oxidation. Okay? So there we see with our oxidation numbers, assigning them, how that can help us to distinguish between an oxidation and a reduction reaction. Now, as we move on, okay, we look at reducing agents and oxidizing agents. Now, ladies and gentlemen, to me, I think of this as the opposite. What do I mean by that? Well, the reducing agent is what is actually undergoing oxidation. So whatever was oxidized is the reducing agent. Whatever is undergoing reduction is the oxidizing agent. Okay? So on our previous slide that we had here, okay, if I go back to this slide, what was undergoing oxidation? Magnesium, right? So the magnesium was undergoing oxidation. So going back here, we would say that magnesium reduces the sulfur. So the reducing agent is the magnesium. Okay? If I look at the oxidizing agent, okay, the substance in a redox reaction that is accepting the electrons is the oxidizing agent. Well, what was accepting the electrons? Well, it was the sulfur, right? It was the sulfur. So the sulfur is the oxidizing agent because it is accepting the electrons. As I look at this equation, it says write the separate oxidation and reduction reactions for the following equation. Well, how am I going to do that? Well, if I look here and I look at the oxidation numbers, okay, and assign those, I have a 0 here, I have a 0 there because they're by themselves. Over here, I see a -1. Cesium is going to be a +1. So as I am looking at that, okay, if I connect my cesiums here, as I do so, all right, what I'm going to have and what I am seeing is that cesium is losing 1 electron. So as I am going to show the half equation here, I would write cesium, okay? Then I would put the cesium as a plus, just like I have here with my oxidation number here. There's a +1. I got the cesium with the +1. And then the 1 electron, because cesium is losing an electron. Losing electrons, ladies and gentlemen, once again, is oxidation. Now, let's go back and look here at the fluorine now. Here is fluorine, right? Here is fluorine. Fluorine now has gained 1 electron. So it is gaining a negative charge because it went from 0 to +1. So I am going to have fluorine, and I'm going to have it gaining electrons. Now, as I look at this, why did I have this 2 here? Okay. Why did I have this 2 here? Well, because I have diatomic fluorine. So each one of those guys had to gain 1 electron. That's why I have the 2 here. Okay. Nonetheless, when we are gaining electrons, we are undergoing reduction. Grr. Leo, grr. Okay. So, as I'm writing a redox reaction, okay, what I need to do here is I want to determine what is being oxidized and what is being reduced. How am I going to do that? Well, I am going to use oxidation numbers, ladies and gentlemen. So when I go through and write my oxidation numbers in, I'm going to start off with these 2 right here because they are by themselves. It's going to be 0. Okay, I can see silver nitrate here. Oxygen's going to be a 2-. Okay, I know that nitrate has a 1- charge total, so it has to equal -1. If I just said oxygen's -2, that gives me -6. That means that this nitrogen here has got to be +5. So my nitrogen is +5. I'm going to get this all out of the way. I just wanted to show you how I did that. Now my silver is going to be +1. I come back over here. I can see this nitrate right here. This nitrate's going to be same as it was just over there. There's a -1. There's a +5 for that nitrogen. This appears to me to be copper 2 because I have 2 nitrates. Each one is a -1 charge. So now I've assigned my oxidation numbers. I want to look to see where my changes are. And I can see, first of all, usually if I have something that has a 0, it is going to be changed from one way to the other. So I see that carbon right here has a 0. Carbon has gone from 0 to +2. That means that it is losing 2 electrons. If I'm losing electrons, I am being oxidized. So copper is undergoing oxidation. What else changes? Well, does nitrogen change? +5, +5? Nope. Does oxygen? -2, -2? Nope. My other one here is silver. So silver went from +1 to 0, so it has gained 1 electron. So when it gains 1 electron, silver is being reduced. So it is undergoing reduction. Remember, Leo Gur. Leo Gur. Leo the lion goes Gur. Oxidation and reduction. Now the oxidation number changes, okay? An increase in the oxidation number is going to signify oxidation. A decrease in the oxidation number is going to signify reduction. Okay? So if I increase the oxidation number, I am losing electrons. If I decrease the oxidation number, I am gaining electrons. Let's look at another one here. Let's look at another one here, and the oxidation number changes. Once again, we have to do the oxidation numbers. Chlorine's by itself. Bromine is going to be a -1 because it's an alkyl, or excuse me, a halogen. Hydrogen's a +1 unless it's a peroxide. Once again, I see I have a halogen and I have a +1. Bromine here is going to be 0. So once again, I have chlorine changing right here. Chlorine went from a 0 to a -1, so it's +1 electron. It's added 1 electron. Gaining electrons means it is reduction. Look at my next one here, bromine. Bromine went from -1 to 0, so it has lost 1 electron. Losing electrons is oxidation. So, losing that 1 electron, oxidation. Chlorine gained that 1 electron, reduction. Here's another one. Once again, let's get our oxidation numbers by themselves. So they're both 0. Oxygen's -2 unless it's a peroxide. This is not a peroxide, ladies and gentlemen. So that means that this carbon must be +4. Once again, carbon goes from a 0 to a +4. Okay? So it is losing 4 electrons. So that is losing, excuse me, check. Losing electrons, okay? Losing electrons is oxidation. Here's oxygen here. Oxygen, connect those two together. It went from a 0 to a -2, so it is gaining 2 electrons. Gaining electrons, Gur, is reduction. Oxidation, reduction. Let's try one more. Now we're getting a little bit more difficult. Because if you look at this baby here, if you look at this one here, ladies and gentlemen, we have a bunch of stuff. Doesn't matter. Doesn't matter. Still go through. Sulfur is going to be a -2. Cadmium's going to be a +2. Now, does cadmium take a +2 charge? I look at my periodic table. Yes, oxidation state of +2. Iodine here is going to be 0. It's by itself. Chlorine's -1. Hydrogen's +1. Chlorine here is -1. Cadmium here is +2. iodine is -1, hydrogen is +1, sulfur by itself is 0. So, like I said before, most of the time when I have a 0, that's going to change. So I'm going to connect my iodines right there. Iodine went from a 0 to a -1. So it has gained 1 electron. So gaining electrons, GER, is reduction. Okay? Gaining electrons is reduction. Where's my other 0? Oh, here it is. It's sulfur. So I'm going to connect these all the way over here. So sulfur went from a -2 right here to a 0 right here. So it has lost 2 electrons. So losing electrons, Leo, is oxidation. Leo, GER. Losing electrons, oxidation. Gaining electrons, reduction. Ladies and gentlemen, this is Mr. Braun. We have been talking about redox reactions. Ladies and gentlemen, let's investigate.